Imagine stepping onto a plane where speed, efficiency, and sustainability aren't just features, they're completely reimagined. Today, we're exploring the most groundbreaking aircraft concepts that promise to change the way we fly forever. From supersonic jets that slash flight times in half to revolutionary blended-wing designs that cut emissions while carrying hundreds of passengers in comfort, every innovation pushes the boundaries of engineering and imagination. Every detail in this video, from design to technology, is crafted to make the future of flying faster, greener, and smarter than anything we've ever experienced. Buckle up, because the journey into tomorrow's skies starts right now. Nuclear-powered Sky Hotel is a visionary airborne resort concept imagined as a self-sustaining floating city that could remain aloft for years, powered by a compact nuclear fusion reactor. Instead of traditional airport runways, it would use vertical docking platforms where smaller aircraft ferry guests directly into a massive airborne structure, merging hospitality with continuous flight above Earth. At full scale, the design envisions space for over 5,000 passengers across luxury suites, world-class restaurants, shopping districts, and observation decks offering full 360-degree panoramic views of the planet below, creating an experience more like a floating metropolis than a hotel. Its ambitious goal is to combine advanced propulsion, sustainable energy, and aerospace engineering to redefine long-duration travel and tourism. Rather than a current engineering program with verified specifications, the nuclear-powered Sky Hotel functions as a blueprint for the far future of aerospace tourism, one that challenges designers to think about sustainability, human habitation, and mobility at planetary scale without compromising safety or environmental responsibility. Varialift Airship is a rigid heavy-lift aircraft concept designed to transform cargo aviation by using variable buoyancy technology so it can take off and land vertically without runways while carrying massive loads over long distances. Unlike conventional airships that rely on fixed helium lift, Varialift's patented system compresses and transfers helium to control buoyancy, making it heavier than air on the ground for easy loading and lighter than air for vertical ascent. Constructed with a lightweight aluminum airframe and outer shell, the airship's design is meant to support a long lifespan with minimal helium loss over decades, and allows large cargo bays accessible by trucks and vehicles before flight. The project foresees multiple variants, including the ARH-50 and ARH-250 models, with lengths up to 300 meters and payload capacities between 50 and 250 metric tons, capable of cruising around 155 miles per hour at sea level and up to 218 miles per hour at higher altitudes while flying up to 30,000 feet. Varialift airships remain in the development and prototype phase, with manufacturing sites planned and early construction underway, but the concept illustrates a bold leap towards sustainable, versatile airborne logistics for future global supply chains. Egan Airship is a hybrid aircraft concept developed by Seattle-based Egan Airships, best known as the Plimp, a novel plane-blimp hybrid that blends features of blimps, fixed-wing aircraft, and vertical takeoff and landing machines. It represents a creative attempt to merge the buoyancy of lighter-than-air craft, the efficiency of winged flight, and the hovering capability usually associated with helicopters or drones. The Plimp uses a helium-filled envelope for buoyant lift, which makes it partially lighter than air and allows it to descend gently without catastrophic crashes if propulsion is lost, a built-in safety feature that slows unpowered descent to about 9.5 miles per hour. Its streamlined shape, lightweight materials, and electric propulsion enable vertical or near-vertical takeoff and landing without a runway, combined with forward flight performance that outpaces traditional blimps. The prototype Plimp drone measures roughly 28 feet long, weighs under 55 pounds, and has demonstrated hovering lift and forward flight up to 40 miles per hour with over an hour of endurance in tested configurations. It can be operated remotely, making it useful for surveillance, inspection, cinematography, search and rescue, and other missions where visibility, stability, and safety are paramount. Detachable airplane cabins are a conceptual aviation innovation that imagines passenger or cargo sections of an aircraft as modular units that can be separated from the main airframe for rapid boarding, flexible configuration, emergency safety, or quick turnaround operations. This idea has been explored by major aerospace engineers and designers as a way to rethink how aircraft are used and serviced. One prominent vision comes from B-Plane, a collaborative research program developing a detachable fuselage system for medium-range aircraft, where the passenger or payload module can be separated from the structural elements of the aircraft, potentially simplifying maintenance, enhancing turnaround efficiency, and enabling highly customizable airframes. Airbus has also patented an aircraft design involving detachable cabin modules intended to streamline boarding and ground operations. In their concept, passengers could board a preloaded cabin pod while the aircraft is still in flight or as soon as it lands, and then the pod could be replaced or reconfigured independently of the aircraft itself, cutting costly turnaround times. Talon A2 is a fully recoverable hypersonic flight vehicle developed by Strata Launch to push the boundaries of high-speed aerospace testing and reusable hypersonic operations. Launched from the massive rock carrier aircraft, known for having the world's largest wingspan at 385 feet, the Talon A2 falls away at altitude and ignites its liquid-fueled Hadley rocket engine, quickly accelerating into the hypersonic regime. On multiple flights, the vehicle has exceeded Mach 5, meaning it has traveled more than 5 times the speed of sound, demonstrating both raw speed and robust performance in extreme conditions. What sets Talon A2 apart from earlier hypersonic testbeds is its fully autonomous flight and runway landing capability. After completing its hypersonic mission profile over the Pacific Ocean, it has glided back and landed on a runway intact, allowing Strata launch teams to recover the vehicle and reuse it for subsequent missions. This reusability greatly reduces cost and turnaround time between flights compared with traditional expendable designs, paving the way for higher cadence hypersonic testing that supports propulsion systems, sensors, thermal protection materials, and other next-generation aerospace technologies. EHang VT35 is a cutting-edge, fully autonomous two-seat electric vertical takeoff and landing aircraft designed to push aerial mobility beyond short urban hops into intercity and regional travel, eliminating the need for a pilot on board. It represents a significant step toward practical, everyday autonomous flight, especially across bay areas, coastal routes, and mountainous corridors. The VT35 uses a lift and cruise configuration with 8 vertical lift propellers for quiet, efficient vertical takeoff and landing, then transitions to forward flight via a rear pusher propeller and fixed wings that boost cruise efficiency. This tandem wing layout balances stability, compact footprint, and performance, helping it operate from vertiports, rooftops, parking lots, or small landing sites. Performance highlights include a design range of about approximately 125 miles on a single electric charge, making it well suited for connections between nearby cities or regions, and a cruise speed above 134 miles per hour that cuts travel times compared with ground transport. Maximum takeoff weight is roughly 2,094 pounds, and the aircraft is built to transport 2 passengers plus baggage with zero carbon emissions during flight. Aufeer-designed Flying Taxi is a concept electric vertical takeoff and landing aircraft envisioned as a sleek, autonomous urban air mobility vehicle that could reshape how people move above congested city streets. At its core, the concept, often referred to as the TX-001, is a 2-seat eVTOL vehicle with 4 protected rotating propellers powered by electric motors and batteries, arranged at the ends of tandem wings to provide both vertical lift and efficient forward flight. This lift and cruise layout balances quiet operation with improved range and stability compared with simple multi-copter designs. The aircraft's carbon fiber composite fuselage and canopy offer panoramic views for occupants, and its tandem wing planform is intended to extend the aircraft's reach beyond short hops, making it better suited for urban and near-urban travel than standalone quadcopter concepts. Redundancy is built into its distributed electric propulsion system, meaning multiple motors and propellers increase safety by allowing continued flight even if one element fails. This concept illustrates what designers believe future sustainable air mobility could achieve, though realization of these ideas will depend on advances in autonomous flight systems, certification frameworks, battery technology, and urban aviation infrastructure. Janus Flying Suitcase Helicopter, officially known as the Janus 1 Flying Suitcase, is an innovative foldable ultralight vertical takeoff and landing aircraft developed by X Control System that reimagines personal flight with extreme portability and modular capability. It's designed to fold down small enough to fit in the trunk of a car and be assembled quickly for one-person flight, blending compact convenience with real rotorcraft performance. Unlike many electric personal VTOL concepts, the Janus 1 uses a turboshaft heavy fuel engine that runs on Jet A, kerosene, or diesel, giving it sustained lift and more efficient long-range performance than many battery-dependent alternatives. Even in its folded form, the core unit weighs about 154 pounds. Yet, once unfolded, it becomes a twin-rotor aircraft capable of lifting a maximum payload of 440 pounds, enough for a pilot and gear or varied mission equipment, with a maximum takeoff weight around 595 pounds. Performance figures show the Janus 1 can fly at cruise speeds around 62 miles per hour, with a top speed near 99 miles per hour, and operate at altitudes above 19,185 feet thanks to its lightweight, high-lift tandem rotor design. Endurance is reported between 30 minutes and up to 8 hours depending on configuration and fuel load, offering flexibility from quick hops to extended missions. The Janus 1 stands as one of the most compact and adaptable personal VTOL prototypes today, hinting at a future where airborne mobility might be as portable and convenient as carrying a suitcase. XBAT is the world's first AI-piloted vertical takeoff and landing fighter jet, engineered to launch and recover without a runway from ships, remote bases, trailers, or rugged terrain, and bring next-generation autonomous air power into real operations. Developed by Shield AI, it combines hive-mind artificial intelligence, fighter-class propulsion, runway-independent VTOL, and multi-role combat capability to transform how modern conflicts are fought. At its core, it uses hive-mind autonomy software, a suite of advanced artificial intelligence algorithms proven in combat flight tests that lets the jet navigate, fly, and engage without pilots, while also operating when GPS or communications are denied or jammed. This autonomous capability allows XBAT to function as a standalone combat asset, or a digital wingman alongside human-piloted aircraft. The aircraft features a tailless blended wing design with a single fighter-class engine and vertical lift technology that makes runway independence possible. Performance targets are striking for an autonomous combat jet. It is designed with a range exceeding 2,000 nautical miles, a service ceiling above 50,000 feet, and the ability to carry internal weapons and external munitions for strike, counter-air, electronic warfare, intelligence, surveillance, and reconnaissance roles. As we wrap up, the reality is clear. These planes are not just inventions, they are the future taking off before our eyes. The breakthroughs in speed, efficiency, and sustainable design will redefine how we move across the globe, making travel faster, cleaner, and more connected than ever. If today's innovations amazed you, make sure to like this video, subscribe for more insights into the technologies shaping our future, and drop a comment telling us which aircraft concept blew your mind the most.